Okay, so we're going to work through some example problems here. I'll probably do one video per problem because they do get a little bit long, and I don't want to make it like an hour-long video. Um, so let's walk through this. This should help you on how to do some of the problems on your worksheet. So let's just read through what it says here. It says one, I should be clear, this is one 193 kilogram curtain. It's one curtain, not a 1,193 kilogram curtain. So we have one curtain, it's 193 kilograms, and it needs to be raised 7.5 meters in 5.0 seconds. Which motor would be best or would be most useful? A 1,000 watt motor, a 3,000 watt motor, or a 5,500 watt motor? And so we probably are going to have to do some math, figure out which one of these we're closest to, and see which one's going to be kind of the most appropriate motor. Because we don't want to go too big, because then it's going to be a waste of energy, but we don't want to go too small, because then it's not going to get the job done fast enough. Okay, so we read the question. After that, I always recommend going back and underlining or circling or doing something to all the numbers in there. So let's see, we got 193 kilograms. We need to raise it 7.5 meters, and our time limit is 5 seconds. Which motor would be most useful? Okay, so these are basically our answer choices. We have 1,000, 3,000, or 5,500. We're not even going to worry about this yet. We're going to do our math first. So before we do any math, let's make sure we know what all these are. So we got 193 kilograms, 193 kilograms. Well, what kind of number is that? Is that a mass, velocity, acceleration? What are we talking about? So that's our mass, so I'll put an M there. Next up, we have 7.5 meters. Well, what kind of information is meters? All right, that's a distance or a change in position, so I'll put delta x there. Then we have 5.0 seconds. Well, what kind of information is that? Is that is that another distance? Is that a force? What are we talking about? Okay, that is a delta t. Cool. So that's that. Now what we need to think about is what equation can we use to take all this information and start talking about watts. Well, hopefully you should have already watched the video, what are watts, and that's going to tell us, but they're, that's basically the unit for power. So I'm going to start off by writing my equation for power. P equals, I'm just going to use my work divided by delta T definition. We could use one of the other ones if we wanted, but I think this will be the simplest. And then we need to start seeing, well, what do I have over here that will match up with what I have over here? And the answer is, unfortunately, not much. We have just the delta T. So what we need to do is we need to think about what is work. So think about what were our equations that we used for work. So hopefully you remember that work is, we can either think of it as the change in energy, which could get us the right answer, but I think a more direct path would be to say that work is force times the change in position, or the delta x. So W equals F times delta x. Well, that's good, because we do have delta x over here, so that's good. But we don't have F, we have M. So what we need to think about here is when you're raising this curtain, think about this like in the auditorium. We've got a big curtain, and we got to raise it up out of the way so that we can see what's on the stage. So what force are we working against when we do that? And that's gravity. Good. So force of gravity. But we don't want we're not trying to do force of gravity here. We're trying to do that opposite of the force of gravity. So we're going to put a negative in front of it. And my equation for the force of gravity would be mass times g, mg, but since it's negative, I'm going to put a little negative here too. And so we have m, good. G, okay, this is like, find one thing and now we got to find something else, right? So what is g? We've known this number all along. I am going to make you put the negative in front of it. So g equals negative 9.8 meters per second squared, and that equals g. And again, the reason we put this negative is because gravity's pulling it down. The reason I want the negative, I made everything negative in my equation here, is because we actually want our force to be pulling up. So we want the negative of the negative, which is going to end up being positive. So if you're like, I don't understand what you're talking about, just know that the negatives are telling us which direction. This negative tells us that gravity pulls down. This negative tells me that I want the opposite of the force of gravity because I'm trying to lift it up, and up is the opposite of down. Okay, so anyways, we've got some different equations here, 3 equations actually, and so what we're going to do is kind of combine them all into one. I am going to take this negative mg, and I'm going to put it in here, so I could say, I'll try to squeeze this in right here. My work equals negative mg delta x, and then I'm going to switch back to red for this one because we're back to our kind of main equation. I'm going to take this and I'm going to put it back up into my first equation. Okay, so let's write that now. P equals, now W, but I'm going to write negative mg delta x, and that came straight from right here, straight from this equation here. So that guy. And then I'm just going to divide all that by, well, no, that's easy. That's just going to divide by delta t. So we did some algebra there and just kind of moved things around and thought about, this is the real physics of the question here. And this is the hardest part. From here on out, it's just take numbers we know, plug them into the equation, and solve. And that's really just math class. I will walk you through it, but I just want you to know that this is kind of, when we say what is physics, this is what it is. Figure out how to use these rules that we know and combine them to answer a question. Okay, so let's do it for real now. So I'm just going to write a little equal sign because we're just going to sort of replace all of our variables over here with their actual number value. So P equals, okay, well, negative, that's still just a negative. Then I want to write my mass, which is 193 kilograms, and my parenthesis got a little bit away from me there, so I do apologize. So 193 kilograms times g, which we said is negative 9.8, and I want to include my negative because, like I said, the direction that everything is pointing is important here, so we make sure we get the right answer at the end. Although if you got a negative answer, you'd probably just say, I probably screwed up, and it's probably supposed to be positive, although you should always go back and check. Okay, now, delta x, that's our change in position, which we know from our question, is 7.5 meters. So I'll write that in here, 7.5 meters. All right, this is getting pretty big here. I'm going to divide all of that by delta t, and we saw from our question before that delta t is 5, and that looks like 5.05 seconds, but it's actually just 5.0 seconds. Or I guess what I'm saying is this S looks kind of like a 5, so that's my bad. Anyways, we've got all the numbers here, so now it's just time to plug it into our calculator and see what we get. So I think you guys can see my calculator on the screen. I'm not sure, so I'm still just going to read out what I'm typing in. So I'm going to hit 193, but it's negative 193, so I got to make it negative. Then I'm going to multiply that by 9.8, but not regular 9.8, negative 9.8, times 7.5. I like to, kind of, once I get done with one section of the equation, just go ahead and hit equals. So we got this 14,185.5. That's my top. I want to divide that by 5.0, or just 5 if you want to save a little time. Then I'm going to hit enter, and I get 2,837.1. So let's write that, 2,837.1. So this equals 2,837.1. What are we talking about here? 2,837 what unit? Well, since we're talking about power, we could just save ourselves a lot of time and say those are just watts. Or we could think, well, we had kilograms times meters again, so that's meters squared, divided by seconds squared, divided by seconds again, so that's going to be seconds cubed. Oh my goodness. Nobody cares about kilograms meters per second cubed. We know that that is the same as a watt, or if you want to think of it as a joule per second, we got joules on the top here divided by seconds. Or you could say, okay, well, these two make a Newton times a meter divided by second. We already kind of went through that. But I think watts are the easiest. If you're talking about power, we're going to be dealing with watts. So that's not our answer, though, right? Like that, we're not finished with the question, because the question is which one of these motors would be most useful. So if we were to choose the 1,000 watt motor, it's not going to be fast enough. It's not, or it doesn't have enough power to do this, and to lift up the curtain in 5 seconds. Maybe it could do it in 10 or 15 seconds, but it's not going to work for what we need right here. Or we could look at the 5,500 watt motor, and yeah, it's like twice as powerful as it needs to be, right? So it's really kind of overkill, unless we needed to actually raise this in 2.5 seconds, or we needed to raise it 15 meters, or maybe it's twice the mass or something like that. But for the question that's given, the most appropriate motor would be this 3,000. Oh god, that's a terrible job. I'm just going to write it down here. So use the 3,000 watt motor. So that was a pretty big question. We had a lot of substituting this in and that in and kind of flipping things around. But I wanted to show you guys that just so that you would have an example, because you're going to have some that are kind of similar on your worksheet assignment. So, this is kind of a walkthrough on how to do that. Hopefully it all makes sense. If not, you can get on the group chat, or you can try to get into the Zoom video chat, and I will help you there. So anyways, that's that, and hopefully that all made sense.